We'll now begin to look at why we need energy resources for development. And what we want to take away from this is to be able to describe different energy-related definitions. And for the most part, we're not really going to go too in-depth with the different types of energy. The book does a pretty good job of describing those. We'll hit on some of the big general topics here, and then also examine energy issues that are related to sustainability and also connect that to the issue of pollution, because that's obviously a very large part of the sustainability issue. So, our definition of energy, as provided by the textbook with Rubenstein, is resources that are used to produce food, transport people and goods, and runs homes and factories. So everything that we kind of use in order to produce food, produce the ability to transport people and goods, and then also in order to run homes, factories with electricity, heat, air conditioning, what types of energy that are used for those purposes. So for the most part, what we end up using for the majority of this production is fossil fuels. So that's things like coal, petroleum, natural gas, just to name a few. And so that's 5/6 of the world's energy. The other 1/6 comes from things like nuclear power, geothermal energy, hydroelectric, solar, wind, and then also human and animal use, and then also biomass. So when I say human and animal, that means like humans and animals, like human labor, animal labor, actually like getting that stuff done. So think animal pulling a plow or human pulling a plow kind of thing. All right. So there we go. So we also need to understand that there's an inequality of energy in terms of needs, demands, and uses. Okay, so most developed countries around the world, think in North America, Western Europe, use the most fossil fuels, although China and India, by individual country, are very, very heavy in their own increase of usage. But for the most part, beyond India and China, the vast majority of actual energy usage with fossil fuels comes from, again, the considered developed or core countries. Though most of the fuels end up coming from the developing world, or the periphery and semi-periphery. Think again back to the idea of secondary and also primary activities. So the extraction of those raw materials, such as coal, fossil fuels, iron ore, oil, those would again fall under the category of a primary activity, while the actual production of it into something useful would be more of the secondary. All right. So again, that is the core taking it from the periphery and semi-periphery. So connecting it back to Wallerstein. Then the supply. All energy supplies are not created equally, because obviously some countries need more supply than others, and then others also heavily use more than other countries in relative size, population. So again, it's not all equal, especially because not all resources are found equally around the globe. So that is another piece for why energy reserves become a very big issue, because some have a lot more, others don't have a whole lot. Especially again in terms of what type of energy you do have, because not every country again has the same types of natural resources. All right. So kind of an example here, even inside the United States, here's natural gas with what we call proven and potential reserves, which we'll refer back to here in a bit. You can kind of see the red areas are the current production. Okay, and again, it's not equal throughout the United States, and a lot of it again comes into waterways as well. All right. So world energy demand, you can kind of see, about 1/3 of it's petroleum, a little less is coal and natural gas, and then you can kind of see here the U.S. demand, where most of ours is coal, natural gas, petroleum. You kind of see a little bit there with nuclear power, and then also the other types, so hydroelectric power, geothermal, wind, solar would be kind of up here, slowly growing over time. All right, and then we used to go back here up until mid-1800s was wood power, so that'd be a biomass fuel. So in terms of current share, China actually is the number one. Then India over here, so the two largest countries in the world make up 1/4 of the world energy consumption. But then when you consider here's the United States and Europe combined, they take up more than China and India. But the concern is here, all right, if we're already considered to be running low on, energy uses and resources, and the expectation is that developing countries, they're semi-periphery, periphery, developing countries are going to be using more and more, and ours will also be steadily increasing. That means that we might actually run into issues of renewable energy, or needing to use more renewable resources in order for us to not have issues of supply when it comes to energy resources. All right. So this ties us into the debate about renewable versus non-renewable resources. So we also need to find what is the big difference here. So a renewable energy source essentially has an unlimited supply and is not not depleted when used, or at least not heavily depleted. So these are things that we can use over and over and over again. So things, again, hydroelectric, geothermal, fusion, wind, biomass, and solar. The issue is how to effectively harness and use this energy, and also the affordability. So something such as solar and wind, as we stated in class, while it is very much more cost effective, it's very heavy on, or it's very cost intensive at the beginning, and then pays for itself over time. Okay, something like geothermal and fusion are way expensive, and the question is, how do we actually use said energy to actually generate power, because we don't have the technology necessarily to do that very well or at optimal levels yet. Well, based on our current infrastructure, we are very, very good at using fossil fuels. And it's not that fossil fuels are not reusable. It's the fact that it just takes for them so many millions of years to actually develop and get turned into fossil fuels like petroleum, natural gas, and coal, that it's practically considered a non-renewable resource because it just takes so long for it to be replenished for us to actually use it. So eventually we will run out of these at some point if we keep using them at the rates we are, or if those rates are increasing, versus not being able to completely harness these powers yet, although solar and wind are continually growing and growing and growing by the decade. So in terms of energy reserves, this comes back to what we saw with that map about proven versus potential reserves. Okay, so a proven reserve is a supply of energy that is remaining in deposits that have been discovered. So we know that these exist for any of those fossil fuels. So again, we know that there's this much coal in this area, there's that much petroleum in that area, there's that much natural gas found in this location. So that would be, it's proven. We know that it's there. Current demands for coal, and this is about a couple of years old by now, this statistic, so about 125 years. Natural gas, about 45. Petroleum, again, these are estimates based on current usage and what we know to exist. Okay. Then we have the opposite of that, which is considered what we call potential reserves. So these are supplies and deposits that are undiscovered, but they are thought to exist. So we believe that there is more energy found in certain parts of the globe that we have yet to really untap them, or to tap them. So the problem with this is we have to figure out, how do we make potential reserves become proven reserves? So again, it's the idea that we don't necessarily know if these actually have energy or enough energy to compensate for the loss of the investment that we're going to make. So one, how potential reserve becomes proven, is undiscovered. So typically at this point in the globe, we know where most of the energy is, or at least what we consider to be current fossil fuels. So it's finding areas that we haven't really looked too deep into. And typically these are often in more remote areas, so think more colder temperatures, more deeper into the oceans, more into wildlife refuges and some places like that. And they're typically smaller and harder to extract because, again, we've already tapped the easiest ones, or the ones that were considered the more obvious to find. The second is enhancing recovery from already discovered fields. And so I use this in the idea of a wringing towel. All right, so if you have water sweat in a towel, and then you wring it, you crunch it up and you smush it together, and then a bunch of liquid falls off. The more and more you do that, the less likely you are to get more liquid out, because again, you've already gotten the vast majority of it on the first few tries. So it's the same thing of, well, if we go back to that place, maybe there's some oil there that we didn't find initially, and that could be true. But again, the more that you've already tapped that resource, the less likely you are to get more and more out of it, and you're going to find less and less. There might still be some there, but how much is, the question, and how much is that going to cost in terms of energy usage to extract it, money to invest to extract it, once you've already kind of hit the jackpot or the mother lode of what was there. Then the last one is unconventional sources. So this is, using methods to extract materials that won't work due to either a lack of money, accessible technology currently, or environmental damage. We talk about this a lot when we talk about, going into the Alaskan wilderness, that we know that there is a lot of natural gas and oil in those areas, but it also comes at what's the cost of that if we were to do it. So hence why we'd be considered unconventional. Another thing I found one time back when I was in college and doing my field service hours were two kids debating about fracking on either the moon or Mars. I don't remember which one, but it's like, that's an interesting idea to get, resources, but that means you have to go to an entirely different natural body out in space, and then you'd have to extract it and then bring it back to Earth. Well, how long would that take? What would be the investment cost? Would that be worth it? What's the damage to either the moon or Mars? So, again, very big discussion topics about these potential reserves. Okay, oil sands and fracking also fit under those because of the considered unconventional, because of the damage and the lack of money and everything with that. I'm going to skip ahead here, so I'm not going to talk about OPEC and oil reserves. You can kind of see there's also a video on oil sands there. I have the same one twice. So here's again our natural gas proven and potential reserves. And that'll take us now to the topic of pollution and climate change. And again, we're not going to go too in depth with this in terms of these notes. So again, a lot of it's kind of already laid out. Just want to hit some of the high notes here. So the definition of pollution, okay, contamination of air, water, and soil by substances that are harmful to living organisms. And that's from dictionary.com. So when we tie this in, we also, based on the book information, is that pollution occurs when there's more waste added to the air, water, and land than the resources available can handle. All right, so that means that we are contaminating more to levels that are not sustainable, or again, that the reason that the environment can actually handle because we're doing more damage. All right, so in particular, air pollution occurs when gases in the air are at higher than average levels, and this comes from the burning of fossil fuels in factories, vehicles, homes. This could also go with the fact that cows are releasing methane gas, and having a lot of cows together increases the methane in the air. And so a lot of that releases carbon dioxide and other gases into the atmosphere. When that happens, it makes it much, much more difficult for the oceans and the plants to absorb a lot of that CO2, okay, that carbon dioxide, which they would usually, absorb, and that way didn't get up into the atmosphere. And this creates what we call the greenhouse effect, okay, where the heating of the Earth's temperature is going up because the CO2 gets trapped in the sun's heat, which raises the temperature, causing climate change. That damages the atmosphere, hurting the ozone layer, and leads to more drastic weather-related events where you see, more drought-like conditions. But then when you see rainfall, it comes so heavy. Same thing with snowfall. Instead of it falling 1 or 2 inches here or there, it's like 6, 7, 8 inches in bigger storms. And you can kind of see here is kind of the growth rate for CO2 emissions. Okay, China has been going way, way up since their industrialization period. India, we've seen the same thing. The United States and the EU obviously were higher, but now those are kind of leveling off. So typically as a country becomes more developed, their CO2 and pollution contaminants goes up. So that is kind of a thing with the more developed you become, especially again with manufacturing, you see those CO2 levels go because that's where a lot of that is put into with factories. All right, and so a lot of other developing countries also face those as well. Air temperature and CO2. Nice Futurama video that explains the greenhouse gas. I'm not going to talk too much about the thing about air pollution and the damage by scale. You can kind of, again, read into that. So in terms of talking about combating climate change, okay, we do emission controls and emission taxes. I think this is the Paris climate deal. Car taxes on emissions. But again, these are few and far in between because not every country and every state has the same laws in relation to this. So you can kind of think about what are the problems with a lot of this stuff because, again, not every country has the same standards or cares or puts in the same investments. This is kind of the countries that do the cap and trade model and cap and taxes. So you can kind of see where that you could find those, and that goes back to those other notes. So some other ideas about limiting carbon dioxide damage: forests. So they capture that carbon and use it to get healthier because that's photosynthesis. They take in that carbon dioxide and spit out oxygen. Unlike what we do, which is, we take in oxygen and spit out, our own carbon emissions, but again, not at all to the same level of damage. So, but again, how do they absorb it? And that gets trapped, but you'd have to plant a lot more trees. Little ice caps video. Then the connection here to industry and air pollution and race. So typically, most of the areas where we see today, anyway, at least in the United States, industrial factories. Areas that have, again, lower standards for regulation of pollutants, of factories, and things of those nature, and who lives by them, okay, are typically people of color and people of lower income. So hence, they are more likely to be, by definition per capita, because of their location, more asthmatic, more respiratory issues beyond just being an asthmatic, more likely to, face issues of, healthcare issues related to pollutants, whether it's in the air or in the water, again, due to their location of factories and things that cause a lot of pollution. Just going to skip through the waste piece. Water pollution, point source, comes from a specific point, water manufacturing, municipal sewage, and then non-point that comes from largely diffused areas, so agricultural fertilizers, pesticides, salt that contaminate the water and runoff and irrigation. That definitely causes a lot of problems. So you can kind of think, here in the Ganges in India, well, what happens when everyone's bathing and, drinking that kind of water? So yeah. So you kind of have, again, an example here, non-point sources that where you see how that runoff going into that water thing. And then we'll talk about Flint a little bit here. And yeah, that'll wrap us up here on our very, very quick talk on energy usage and climate change.